Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the centrifugal force in details. What is the direction of centrifugal force? The different numericals, different problems related to centrifugal force. That is all about the centrifugal force. Now, how a centrifugal force developed? Start about the class. What is the centrifugal force? How it is developed? When a body rotates in a circular path. So what happens? Suppose this is a rod and a stone is tied by string and it is being rotated in a circular path. It is being rotated in a circular path. What happens? First, this is a rod, this is a rod, this is stone, and this is string. This is string, and the stone is rotated in a circle. Now, what? That is, first centripetal force is required for rotating the circle. First centripetal force, that is, we pull the stone towards the center. Always pull. We always pull towards the center. Now, if we pull always, then the stone comes towards this direction. So, what is the actually how circular motion is developed? Can you experiment how circular motion is developed? If the stone is pulled direct towards the center, then it is directed towards the center. So, no circular motion is developed. But if it is projected tangentially, then it moves in this direction. Then how can we the circular motion is developed? Can you produce circular motion? Circular motion is developed first. You provide a tangential force. First, you have to provide a tangential movement. Tangential. First, you provide a tangential force. Then you pull always towards the center, produces circular motion. So first you have to apply the tangential force, and then you pull the tension towards the center. Then the circular motion will be developed. So this is the now this force is called centripetal force. And when the body is being rotated, when the body is rotating, then the centrifugal force is produced. So first centripetal force is required to produce the circular motion. If the body is in the state of circular motion, then centrifugal force is produced. So centrifugal force acts radially outward along the radius. Radially outward, that is radially outward. So Fg equal to centrifugal force. Now here another force is produced. If the body rotates in a circle, that is if the stone can rotate, if the stone rotates in a circular path, then and if this rod is loosely held, then what happens? If the rod is loosely held, what happens? The rod after some rod moves. If the rod is held loosely, then rod tilt in this direction towards outward direction. What is the cause? Due to this force, a reaction force act on the rod in this direction. So this force is caused due to this force. So that's why Fr equal to centrifugal reaction. If the body moves with velocity v, then Fc, Fg and Fr, all the value will be same, which is mv square by r, where r is radius of the circle. So first centripetal force is required to rotate the circle, and when the body is once set in the circular motion, then centrifugal force is developed, which is directed radially outward. This is directed radially inward. And this is act radially outward, and the centripetal force is directed. Centripetal force is act on the body towards center. Centrifugal force act on the body radially outward, and Fr is not act on the body. Fr is acts on the rod Fr acts on rod, centrifugal reaction. So 3 force will be same, which is equal to mv square by r. Of centrifugal force is called the studio force. Centrifugal force is called a studio force. That is, we cannot understand the studio force from a, we cannot realize the centrifugal force from inertial frame of reference. That is, when suppose a waterful bucket is rotating in a circular path, vertical plane, circular motion in vertical plane. A waterful bucket is rotating in a vertical plane in circular path. Then at the topmost position, the water may not fall. If the bucket is set in rotation with sufficient speed, with sufficient angular speed, then the water may not fall, because here a centrifugal force acts in this direction, which balance the weight of the water. So if the omega is sufficient enough to balance the weight, then the water may not fall. That is, if the car is rotated, if the waterful bucket is set in motion in vertical circle, then centrifugal force act on the water in this direction, so this balance the weight. So at the topmost position, the water may not fall. So a pseudo force acts in this direction. This is pseudo force, because we cannot understand that force. Another example of pseudo force is that this is centrifugal force, as well as it is called pseudo force. So suppose a car, when a car takes turn in circular path, suppose this car turn in circular path, and the man sitting inside the car feels a man sitting in this car. The man sitting in this car feels the weight outward. The man sitting inside the car feels the weight act in outward direction, radially outward, which is mv square by r. That is, the man sitting inside the car feels that a force act radially outward, acts on him, but from the ground a man cannot realize this force. So pseudo force can realize from the non-inertial frame of reference. What is non-inertial frame of reference? Which has acceleration, non-inertial frame of reference. That is, it has an acceleration not equal to 0, and this is ground. This is called inertial frame of reference. That is, acceleration equal to 0. So from inertial frame of reference, pseudo force cannot be realized, but from non-inertial frame of reference, that is, the car accelerated is in acceleration, which has an acceleration. From that inertial frame of reference, pseudo force can be realized. Now, pseudo force can be realized. Now, what are the different problems? So first, death oil, the motion of the force acting on the bike on death oil. The force acting on the bike on the death oil. Suppose this is a death oil. The bike can, suppose this is a wheel. This is a wheel. That is, the bike can rotate in this death oil with a speed, with angular velocity, such that the bike cannot fall along the oil. The bike cannot fall on the oil. So this is death oil. How he balances his weight as he moves with an angular velocity. Then centrifugal force act in this direction. Which produces the normal direction. Now weight of the bike is mg, balance by this normal direction, balanced by the friction force mu into n. So mg balance the friction mu. F equal to mu into n. Now mg balanced by friction force, which is equal to mu into n, and n equal to m omega square r. So cancel m both sides. So omega square equal to g by mu r, and omega equal to root over g by mu r. So centrifugal force act in this direction so that the bike cannot fall along the way. Another way. Now suppose this is a disc. This is a disc, rotating disc. This is a rotating disc. Rotating disc. Now this is rotates with angular. The disc rotates with an angular velocity omega. Suppose here at a distance. Suppose at a distance r, if a coin of mass m is placed at a distance r, or a ball. Suppose a ball of mass m is placed at a distance r, and if the coefficient of friction mu is given, what is the value of omega for which the ball cannot fly, the ball cannot move. So if r is given, mu is given, what is the value of omega so that ball cannot move? So what is the equation of motion? Here the ball can slip. Here the centrifugal force act on the ball in this direction, m omega square r in this direction, and friction prevents the slipping of the body. So friction F equal to mu into n, which prevents the centrifugal force. So mu into mg equal to m omega square r. So omega equal to mu g by r root over. So this is the answer. Okay. Now if the question comes this type, suppose this is a rotating disc. Suppose this is a rotating disc. The axis of rotation is this, and a string of length, suppose a string of length a, and is two mass tied by string. The mass, this mass is m, and this mass is 2m. This mass is 2m, and this mass is m. This mass is m. Is tied by string, and this radius, this distance is suppose a. This is a. So this distance is a, and this length is also a. Suppose this length is 2a. This length is a, and this length is 2a. The disc is rotating with angular speed omega, and coefficient of friction between surface and this ball is mu. Now find the tension. Find tension of string and value of omega for which two ball remains in equilibrium. So this is the question. Find tension of the string, and find the value of omega for which the string can the balls remains in equilibrium. Now to solve the problem, if we draw the pivot diagram, the different force acting on the ball is this ball of mass 2m rotates in this circle, and this mass rotates in this circle. So the centrifugal force. So if we draw the pivot diagram here, this is the mass 2m. So centrifugal force act in this direction, which is 2m into omega square a, and friction act in this direction. Friction equal to mu mg 2m into g. and a tension act between the string. This is the tension T. Now for M, the M rotates in this direction, so centrifugal force M omega square R. What is R? R, this ball rotates with a radius 2a plus a 3a, with a radius 3a, and tension act in this direction T, and friction force act in this direction mu into mg. So this is the equation of motion. So now for the two balls will remain equilibrium if this plus this, that is centrifugal force plus tension, balance the mu mg. So equation is T plus 2m omega square A equal to mu into 2m g. This is equation 1, and this 3m omega square A equal to T plus mu m g. Okay, centrifugal force act in this direction, so friction act in this direction. Now here centrifugal force acts in this direction, tension T act in this direction. So due to this force, the ball tends to move outward, so so friction act in this direction. So equation is this T plus this equal to this, and this plus this equal to this plus this. So these are the equation. Now if we solve, we get T and omega simultaneously. So from T, if we find the omega first, we put from 2 T equal to 3m omega square A minus mu mg equal to this. Now put so omega square equal to cancel 3 mu g divided by 3a. So omega equal to root over mu g by a. This is the answer. Okay. So this is the answer for this angular speed. If the angular speed is omega, then the two balls remains in equilibrium. If the angular velocity greater than this value, then this will shift radially outward. Now what is the tension of the string? Tension of the string is T equal to 3m A omega square. Omega square value is this mu g by a minus mu mg, which is equal to 3m mu g minus mu mg, that is 2m mu g. And this is the tension of the string for this omega. So understand this. I hope all you understand this problem and solution. Now next problem is, suppose a tube, or a water full or a liquid full tube. This tube is rotate about this vertical axis. This tube is rotate about the vertical axis, and mass of the is omega. Length of the tube is this. And the next problem is, suppose a rectangular tube, liquid is full, and this tube is rotate about the vertical axis with angular speed omega. Length of the tube is L, and mass of the tube is m. What is the force acting at the end side? What is the force acting on the end? Total mass is m. It is rotating with angular speed omega. Length of the tube is L. What is the force acting at this end? Here different section. Suppose this section rotates with this circle. This section rotates with this circle. So here different centrifugal force act on different section. We have to calculate the total force. Total force act at the end point. So here we have to first we find what is the force acting at any section. If this mass is dm, and we know angular speed at every section is constant, linear velocity is maybe changed, but omega is constant, and as the distance increases, v changes, velocity changes, linear velocity changes, but angular speed is constant because r is varies, so v is varies, but omega is constant. So when a body, remember that when a disk rotates with angular speed omega, then that is from the axis. Suppose this is axis of rotation. Now this particle has both the same angular velocity, but this particle has linear velocity less than this, because here velocity equal to r2 omega, here velocity equal to r1 omega. So as r2 greater than r1, this velocity is more, this tangential velocity is more, because omega is constant but distance is more means velocity is more. So if we want to calculate at this centrifugal force at this section, so what is the force? dF equal to dm into omega square into, suppose this distance is x and we consider this length is dx, so m omega square x. Now what is dm? dm equal to mass per unit length into length, mass per unit length into length, m by l, which m by l is the mass per unit length and this length is dx, so dm equal to this into omega square x. So df equal to this. Now f equal to integration of df, so x varies from 0 to l, that is m by l omega square x dx 0 to l, so m by l omega square x square by 2 0 to l, which is equal to m omega square l square by 2 into 1 by l, that is half. So answer is half m omega square l. This is the answer. Okay. So if a tube of length l or mass m, if a liquid of mass m is filled in the tube of length l, now if the tube is rotates about the vertical axis in horizontal plane with angular velocity omega, what is the force acting at the end of the tube? The answer will be this. The next problem is if a bowl, suppose this is hemispherical bowl, this bowl is rotating about the vertical axis with angular speed omega. Now if a ball is placed, a ball is equilibrium at an angle alpha. If a ball is in equilibrium of the smooth surface is smooth, but the ball is in equilibrium at an angle alpha. So if the ball of mass m is in equilibrium at an angle alpha, find the angular speed omega. What is the question? What is the answer? Now if we draw, the radius of the hemisphere is r. The radius of the hemisphere is r. This is radius r. Now observe that this ball rotates in this circle whose radius is smaller, suppose smaller. Now centrifugal force act in this direction, m omega square r in this direction, weight acts in this direction, weight act in this direction. Now a normal weight act in this direction. Now a normal force act in this direction, so the result normal along this and this angle is alpha, so this angle is alpha, that is this component is n cos alpha and this component is n cos alpha n sin alpha. So we get the component n sin alpha balance the centrifugal force omega square r, and n cos alpha balance the weight mg. So if we divide this, we get tan alpha equal to omega square r by g. Tan alpha equal to this, so alpha is given, so we get omega square equal to g tan alpha by r. Now we get what is the relation between small r and capital R. This is capital R and this is alpha, so we know from this triangle cos alpha equal to cos alpha sin alpha. we take sin alpha. Sin alpha equal to perpendicular hypotenuse small r by capital R. So small r equal to r sin alpha, which is equal to g tan alpha by small r equal to r sin alpha, which is equal to g sin alpha by cos alpha, g by r cos alpha. So omega square equal to this. So omega equal to root over g by r cos alpha. This is the answer. Okay, this is the answer. So if a hemispherical ball rotates with an angular speed omega and a ball is in equilibrium at an angle alpha, then what is the angular velocity for which the ball remains in equilibrium at an angle alpha? So this is the answer. The next problem is if a ring suppose this is a ring, this ring is of radius r rotates in a horizontal plane, rotates with omega in a horizontal plane, and ring radius r rotates with omega in a horizontal plane. What is the tension of the ring? What is the tension acting? Find tension acting on the material of ring. So this is the question. A ring is rotating with angular speed omega, radius is r. So find the in a horizontal plane, that is this plane, not vertical plane, horizontal plane. This should be mentioned, horizontal plane. That is suppose the ring is placed on a horizontal table and it is rotated with angular speed omega. What is the tension acting the material of the ring? This is the question. I hope you can understand the question. So if the ring rotates with angular speed omega, then a tension act in the material. So we find that what is the tension act in this material. Now take a component. Suppose we take this component, we take this component of the material, this component, we take this part of the material of the ring. Now if this part makes an angle d theta, then the tension act in this direction and act in this direction. So this is the tension T, this is the tension T, act in this direction. Now if we resolve tension along two components, this and this, again this and this. Now what is the angle this? So d theta, we divide this angle as d theta by 2, d theta by this angle d theta by. So this angle is d theta by 2, alternate angle, this and this alternate, and this is this. Now this and this is perpendicular, so this is 90 minus d theta by 2, and this is this and this perpendicular, this and this perpendicular, so 90 minus this angle is d theta by 2. So this is the tension T, this angle is d theta by 2, so component is, this direction is T cos d theta by 2, and in this direction component is T sin d theta by 2. Same way, this direction is T cos d theta by 2, and this direction is T sin d theta by 2. Tension is in this direction is this. Now we see that this component balanced by this component, and this act towards the center, and centrifugal force act on this part is, if this part is m omega square into r. So this force, the ring is not expanding, ring remains same, radius of the ring remains same, so this force must balance this force. So this m omega square r balance this force, 2 sin d theta by 2. Okay, for now if m omega square, what is the mass of this part? If this angle is d theta, mass is, total mass of the ring is m, so mass of this part is, if this length, what is this length? Length dl equal to dl, length of the material dl equal to what? R into d theta, material. Now mass equal to mass per unit length m by, what is the length? Length will be 2 pi r, circumference is the length. Here mass is distributed along the circumference, so mass per unit length into d theta. What is d theta? Value of d theta is, equal to, mass per unit length into dl. Now what is the value of dl? dl equal to r d theta. r cancel, so this and this cancel, so m by 2 pi into d theta. This is the mass dm, so dm or m, this is dm, this is m, okay, mass of this element is m, so we put m equal to m by 2 pi d theta into omega square into r. Now we want to calculate the tension part, 2t sin d theta. Now this angle is very small, consider when we take the d theta, that is angle is very small, so sin theta equal to theta d theta by 2 cancel. Now here d theta cancel, d theta, so t equal to m r by 2 pi. So this is the answer, m omega square r by 2 pi. Now here 2t sin d theta by 2 balance the m omega square r, so here dl equal to r d theta, so mass equal to mass per unit length m by 2 pi r into dl is r d theta, r cancel, so m d theta by 2 pi. So mass equal to m d theta by 2 pi, omega square r equal to 2t sin theta is theta. 2 cancel, d theta cancel, so t equal to m omega square r by 2 pi. This is the answer. Mass is given, omega is given, r is given, so this will be the answer. Tension of the string. Horizontal plane, motion of a particle in horizontal plane, and shape is conical pendulum shape. Suppose a stone is rotating in a horizontal circle such that it makes an conical shape like this way, conical shape. Suppose the stone is rotating in horizontal plane such that it makes an conical shape. If the length of the string is L and mass is m and it rotates with angular speed omega, what is the tension of the string and what is the relation between h and omega? What is the relation between h and omega? So find an equation of this motion. Now what is the different force acting on this system, on this mass? Here tension T act in this direction. If this angle is theta, then this angle is theta, so this is T cos theta, and mg balance this force, so this is T sin theta, T cos theta balance the weight, and T sin theta balance the centrifugal force m omega square r. Okay, now 2 divided by 1 we get tan theta equal to omega square r by g. Tan theta equal to this. Now this is r, this is h, tan theta equal to r by h, so this equal to omega square r by g, omega r cancel, so h equal to g by omega square. So this is the relation between g and h and omega. Now what is the tension? We get tension from 1 and 2. If we squaring 1 square and 2 square, we get T square, which is equal to equal to so T equal to root over so this is the answer, this is the tension stand, and this is a rod attached with this stand, and a string of length L, the stone is tied at here, and it is rotating with a circle. It is rotating with a circle. A string of length L is rotating in a circle. In a circle, this length is L. This length is L, and this angle is theta, and this length is L. Mass of the stone is M. So this is a stand. This is a rod attached. The length of the rod is L, and a string of length L is attached at the end of the rod, and it is being rotated in a circular plane or circular horizontal plane. When if the string makes angle theta, what is the value of theta is given? Theta is given. Find the omega. Omega for what value of omega? Thus this string makes an angle theta with vertical. For what angle of omega? This string makes an angle theta with vertical. So this is the question. Now solution is that if we draw the different force acting on the mass, what force act? Here centrifugal force act in this direction. Now what is the R? R will be this. This is the R. And weight act in this direction, and tension act in this direction. So if we resolve T, this is theta, this is T cos theta, and this is T sin theta. Okay, T cos theta, T sin theta. So T sin theta balance the centrifugal force m square r, and T cos theta balance the weight. Now tan theta equal to omega square r by g. So omega equal to g tan theta by r root over. Now if what is the value of r? If we find the r as what is the r? R equal to this plus this, L plus what is this? This length is L. The L cos theta, this is L sin theta. L sin theta. So r is L plus L sin theta. Put here, you get the value. So this is the answer. Next problem, suppose a rotor, this is a wooden drum which is rotating with angular speed omega. Now a man hold the drum, and coefficient of friction between man and this surface is mu. A man of mass m hold the drum in inner side and just is in equilibrium. So for what value of omega the mass can remain in equilibrium? That is the man can not fall. The man cannot. For what value of omega the man cannot fall? So in this type, what is the different equation? Weight of the man act in this direction. So friction prevents the slipping of the man. Friction will be what? F equal to mg. Friction equal to what? Friction equal to mu into n normal direction. What is the normal direction? Normal direction act in this direction. So for this force, centrifugal force must act. So that is for omega a centrifugal force. For omega a centrifugal force act on the man. So a normal direction act on the man such that friction force developed. So friction force equal to mu into n. which is equal to mg. Now what is mean n equal to m omega square r equal to mg. So mm cancel, so omega equal to g by mu r, omega equal to root over g by mu r. Next problem is, suppose this is a these are two blocks and a rod, two same mass, two blocks of same mass m are attached at the end of rod, and the whole system is rotating with angular speed omega about the axis which is passing through the perpendicular bisector of the rod. Now if the maximum tension of the rod is T0, find omega, so that the block of mass m does not break from the string, does not separate from the string. That is, for what value of omega this block don't separate from the string. So the maximum tension here given is T0. T0 is maximum tension is given. So what is the force act if this length is given L, this length is given. Now what is the force acting at that point? The force act on this point is m omega square L. So m omega square L will be the tension of the string. If this force greater than T0, then the block of mass m separate from the string. So this is the equation. So omega square equal to T0 by ml, omega equal to root over T0 by ml. So these are the problem of centrifugal force. Also in Newton's laws of motion, different apparent weight on the lift and a car on the lift is given. Suppose a car is accelerating with acceleration a. This is centrifugal force, no? Centrifugal force. Okay. Students, this is the end of the class today. To get more video on centrifugal force, watch my another video. Okay, thank you. To get such type of video, subscribe my channel. Okay, thank you.